Ever wondered how a simple Python script can somehow manage an entire store's worth of stuff? Well, today we're going to tear one of those scripts down and see exactly how it works, piece by piece.
I mean, really think about it for a second. How does a single program keep track of every single item, handle sales, update the stock levels, and not miss a single beat? You know, it seems super complex on the surface, but the logic underneath it all, it's actually surprisingly simple.
So, we're going to approach this just like we're playing with building blocks. If we can understand each individual block, then seeing how they all snap together to create a really powerful, complete system becomes way, way easier.
All right, first things first. Before we can sell anything, we have to define what an anything even is, right? In our store, that's a product. This is our most fundamental, most important building block. So to define what a product is, we use a concept in programming called a class. And honestly, the best way to think of a class is like a blueprint for a house. It's not the house itself, nope, but it's the super detailed plan for how to build any number of houses that are all structured exactly the same way.
And at the heart of that blueprint is this special function, a constructor. In Python, you'll see it as __init. Think of it as the factory's assembly line. Every single time we want to create a new product, this function kicks in and it demands the essential info, a unique ID, a name, a price, and how many we have in stock. And why do we do this? Well, it guarantees that every single product in our system has the exact same structure. No missing prices, no weird incomplete data. It's like a contract that keeps our whole inventory clean and reliable.
Okay, so this is where that abstract idea gets real. Let's walk through it. We take our blueprint, that's the product class. Then we feed it the raw data, an ID, coffee mug, the price, and the stock. The __init method gets to work. It's like the construction crew on the job site. And then bam, out comes a fully formed, unique coffee mug object that our program can now track and manage.
Okay, so we have products, now what? We gotta sell them. And that brings us to our next building block, the transaction. We're moving from the static thing in our store to the dynamic action of a sale.
And just like our product, an invoice has its own blueprint, its own class. It needs to keep track of a bunch of key things: who the customer is, when the sale happened, what they actually bought, and of course, all the money details. Every single one of these points becomes a core piece of our invoice class.
And this right here, this is a perfect example of a business rule that's baked right into the code. A fixed tax rate of 18% gets applied to every single sale. No exceptions. By setting this up as a constant in our code, we get consistency and accuracy every single time. It's a non-negotiable part of how our little store operates.
Now this is where things get really cool. This is how our separate building blocks actually talk to each other. When an item is sold, the invoice object doesn't just sit there holding data. It sends a message directly over to the product object, and that message is simple. It just says, hey, one of you was just sold, you need to update your stock level.
And here's the other side of that conversation. The product object is always just listening for that message. It has a specific function, this update stock method, that's ready to spring into action. The second it gets that signal from the invoice, it just subtracts the quantity that was sold from its own stock count. Now this is the real magic of good software design. The invoice doesn't care how the stock gets updated, and the product is totally in charge of its own data. This separation of duties makes the code so much cleaner and easier to work with. So we have products, we have invoices that sell the products, but what's keeping track of all the products at once? We need a manager, a central brain that holds everything together and orchestrates the whole operation. And that's our inventory manager class. This class is the real workhorse of our entire system. It's not just a simple list, it's a full-on manager with a clear set of jobs. It's in charge of adding new items, letting us see everything we have, allowing us to make updates, and this is a big one. It knows how to find one specific product in a sea of thousands. But it also has two very, very special jobs: loading and saving. And this is the million-dollar question for pretty much any application, isn't it? If all our product data just lives in the computer's temporary memory, the second we turn it off, poof, our entire store just vanishes into thin air. We need a way to make our data stick around.
And here's how we solve that problem. This save products function takes all our product objects that are currently in memory, and it converts them into a simple universal text format called JSON. The result is this file, products.json, a clean, human-readable record of our entire inventory. This file is our store's permanent memory, saved safely right on the hard drive.
Okay, we've built the engine, we've built the memory, Now we need to build the dashboard. We need a way for an actual person to interact with all this code we've just put together.
And here it is. I know, it might look almost too simple, but this little text menu is the command center for our entire system. Behind each one of these 5 choices is all that powerful logic we've just spent time building. This is the bridge between the user and our code.
This table really connects all the dots. So when you, the user, presses 1, the program doesn't just see a number. It knows to call the add product function inside our inventory manager. And when you choose 4, it kicks off that whole process of creating an invoice and updating the stock that we looked at earlier. Every simple choice triggers a powerful, predefined chain of events. And that really is the main takeaway here. By starting with these simple, well-defined building blocks, our product, our invoice, and our inventory manager, and then teaching them how to communicate with each other, we've built a complete, self-contained system. That is the power of good design.
And that brings us to a final thought. This whole system works perfectly, but it's locked down to a single computer. So what would it take to turn this into a web application that anyone could access? How would you handle, say, multiple people trying to create invoices at the exact same time? That is the next frontier and the logical next step from a solid foundation just like this one. Something to think about, for sure.